in question 2 we have to suggest an identity for this compound Z based on a whole bunch of information. This is quite an important kind of question, and the most important thing you need to realise is that you have to take account of all of the information. Sometimes you don't even really need it all in order to figure out a structure, but even then you still have to show how your structure is consistent with all of the information that's there. So that is something you need to practice as you go through and learn more types of information that you can interpret. So in this case the starting point was that it gave you this composition by mass, and the easiest thing to do with it is to use the standard empirical formula method that you learnt in the first term. So you construct a table and you record a mass for each element across the top. It doesn't matter that they're not percentage masses, you can just write down the actual masses like that. And then remember, what you do is you divide by the relative atomic mass for each element, because that turns them then from being relative masses, which they are at the beginning, into relative moles, which is what you want. And then you divide by the smallest of the 3 numbers you get, because that will, with a bit of luck, then give you whole numbers, which is what you need for the empirical formula. And if you do that, you get this. And these numbers give you your empirical formula. So you can then write down empirical formula is C7H14O. Okay, it's important you actually write that down, not just leave those numbers there. And it's also important that you make it clear that this is the empirical formula, not necessarily the molecular formula, because the molecular formula could be any multiple of that. So, you know, it could be, C21H42O3 or whatever, like that. So that's the empirical formula. To get the molecular formula, you have to calculate the MR from that. So the calculated MR of 7 carbons, 14 hydrogens and an oxygen is 114. And then you say that that's consistent with the molar mass. Which is 114 grams per mole. And that tells you that, in fact, this is the molecular formula. But you need, again, to say, make sure you've said that explicitly, that the molecular formula is the same as the empirical formula in this case, because the empirical formula gives you the correct MR. So the molecular formula is also C7H14O. So the first thing that probably I would notice then is that the number of hydrogens is too small for it to be a simple alcohol. You know, so for example, if it was something like 7OH, you know, that is C7H15 OH. Okay, so if it were just a simple saturated alcohol, it would be C7H16O, not C7H14O, and I think that's worth, 16O, and I think that's worth commenting on, because that means that there must be either a double bond or a ring to account for the fact that there are 2 fewer hydrogens than you would expect for a simple alcohol such as that. So with that in mind, we then look at what sort of evidence we've got available. So we have one very relevant piece of information straight away there, which is that there's no reaction in the dark with bromine. Okay, so no reaction with bromine in the dark. And that immediately tells us that one of the possibilities we might have considered, which is that we might have had a C-C double bond, is not the case, because if that were the case, that would be an alkene group, and alkenes, as we know, do react with bromine in the dark. So we can say that it's not an alkene. So we've still got to think, right, how are we going to get either a ring or a double bond but not an alkene group. And there are basically then two possibilities. So we could have an alcohol with a ring, or we could have an aldehyde. Because an aldehyde, well, it could be an aldehyde or a ketone actually, as far as we know at this point, because they contain a double bond, C double bond O. So a C7 aldehyde or ketone would have that molecular formula. So that would be a possibility, or this would be a possibility. And in fact, it will turn out that either of those can give a possible answer. So let's just follow them both through. So let's try this route first of all, an alcohol with a ring. The next piece of evidence then is that you get reaction with aqueous acidic potassium dichromate, and that immediately narrows it down a bit, because that tells you, well, it can't be a tertiary alcohol, because tertiary alcohols, remember, don't react with aqueous acidic potassium dichromate, but to form an acidic organic product. And that means a carboxylic acid. Aldehydes are ketones, not acidic compounds. But carboxylic acids, obviously the clue is in the name, carboxylic acids are. So that would mean that the carboxylic acid group is formed by oxidation, and that in turn would mean that if compound Z is an alcohol, Z would be a primary alcohol. Okay, because if Z were a secondary alcohol, then when you oxidized it, all it could do is reach the ketone stage, and then ketones you can't oxidize anymore. And ketones are not acidic, so wouldn't fit with the ketone. Sorry, wouldn't fit with a secondary alcohol. As I say, not a tertiary one because they don't oxidize at all, but a primary one. If you undergo prolonged oxidation, then you can convert them into a carboxylic acid, so that would fit. Okay, so now we've got to have an alcohol that contains a ring and which is a primary alcohol. And of course that's significant because you couldn't then have, for example, have a 7-membered ring, like that, and say, oh, well, it could be that, because that's secondary. So at the very least, you would think, well, okay, it has to be not directly attached to the ring. So you could have something like that, and that would fit so far, but does it fit the whole picture? The extra bit of information that we've got is that there's no reaction with concentrated sulfuric acid. Now remember, is the dehydrating agent for alcohols. It takes away water from an alcohol by taking away the OH group from one carbon and a hydrogen from the adjacent carbon. So if it were that structure, it would react because you've got the OH group there, you've got a hydrogen here, so it can't be that, because that would give an alkene in the way that most alcohols do. So the lack of reaction with conc sulfuric acid is very important. So let's write down what that means. So we've got no reaction with concentrated sulfuric acid, which means that there's no hydrogen on the carbon next to the one with the OH. Okay, so just to be very clear, what we're saying here is that, remember, the way the elimination reaction with conc sulfuric acid works is that you have to have these two adjacent carbons, one with an OH on and then the next door one with a hydrogen on, because then you can take that lot away to form water, and it gives you your alkene group here, like that. But that's only possible if the carbon next to the one with the OH has a hydrogen to eliminate. So the fact that it doesn't react tells you that there would be no hydrogen on the carbon next to the one with the OH. So we've got to come up with a structure then that has a ring of some sort, and then a carbon that's not part of that ring, but that's attached to it with the OH group, so that it's a primary alcohol. But then this carbon, which is part of the ring, would have to have another carbon attached to it, so that, for example, this would work. Okay, so that structure fits, because you can see if we go through all the things, does it fit the molecular formula? Yes, it does, because we've got 7 carbons, 14 hydrogens and 1 oxygen. It's not an alkene, so it doesn't react with aqueous bromine in the dark. It is a primary alcohol, because the carbon with the OH has just one other carbon attached, so that can be oxidized through to a carboxylic acid. And it has no reaction with conch sulfuric, because this carbon is the one with the OH, and the next door one has no hydrogens on board, and therefore water can't be eliminated from that to form an alkene. So that would be a possible answer. You could come up with other possibilities with smaller rings, and if they meet all those criteria, then those would be fine as well. But that is one possible type of answer, and you just would need to make sure you'd accounted for all of these things and explained clearly what each one meant. Okay, so explain that the lack of bromine means it's not an alkene, like a reaction with bromine. The reaction with dichromic to form a carboxylic acid tells you it's primary, you should be saying that. And the lack of reaction with conch sulfuric tells you there's no hydrogen on the next carbon. Explaining clearly what you learn from each piece of information matters. Let's just look at the alternative answer. You don't need to do this. If you've come up with that as a possible answer, then that's fine. You can stop there, because it just asked you to suggest a possible structure. But if you didn't go down that route and you chose to go down this route instead, and we said, right, it's an aldehyde or ketone. So again, we look at the information. So the reaction with aqueous acidic potassium dichromate, that immediately tells you it's an aldehyde, not a ketone. So that means aldehyde, because ketones don't react. And so again, that fits with the carboxylic acid group, which is acidic, being formed by oxidation. Okay, so that piece of evidence then narrows it down from either aldehyde or ketone, which fitted down to that point. We're saying, well, no, it has to be an aldehyde. No reaction with conch sulfuric acid. Well, you don't know any reaction of aldehydes with conch sulfuric acid anyway. So you could say, well, that's as expected for an aldehyde. That's a reaction that you've only learnt for alcohols, not for aldehydes. So that would be a slightly odd piece of information, and obviously that was there because this was what we were expecting you to come up with as the answer. But this be fine, and you just say, well, that's expected for an aldehyde. And then you can basically have any saturated C7 aldehyde. So you could have, I mean, the simple one would be 1, 2, 3, 4, 5, 6, 7 with the aldehyde group on the end, but obviously you could have any branched one you felt like, but it's got to be saturated, because otherwise you'd have too few hydrogens. So, you know, you could go to that or something if you wanted to do something a bit different. Yeah. So lots of possibilities there. So that's not uncommon, that you will get questions where there is more than one possible answer. But the main thing is that you have a complete story for the one that you've come up with to show how it's consistent with all of the information.